G6PD. G6PD stands for glucose 6-phosphate 1-dehydrogenase. G6PD deficiency is the most common human enzyme defect, affecting more than 400 million people worldwide. G6PD is negatively regulated by acetylation on lysine. G6PD is a key enzyme in the Pentose Phosphate Pathway and plays an essential role in the oxidative stress response by producing NADPH. Human glucose 6-phosphate dehydrogenase, also known as G6PD, is NAD+ dependent and catalyzes the first and rate-limiting step of the pentose phosphate shunt. The catalytic activity for G6PD is D-glucose 6-phosphate plus NADP+. Glucose 6-phosphate 1-dehydrogenase pathways affected are carbohydrate degradation pentose phosphate pathway and D-ribulose 5-phosphate from D-glucose 6-phosphate. That's the oxidative stage, step 1 of 3. G6PD deficiency was discovered during an investigation of hemolytic anemia occurring in some individuals treated for malaria with 6-methoxy-8 aminoquinolone drugs during 1926. Ingesting fava beans has been known to induce hemolytic anemia in some individuals. Pythagoras warned his disciples not to eat beans. All patients with favisms are G6PD deficient, but many G6PD deficient individuals can eat fava beans without falling ill. G6PD deficiency has been known to destroy red blood cells and oxidatively damage reduced glutathione. When red blood cells are exposed to oxidative stress, they will burst in a G6PD deficient individual because there is not enough reduced glutathione to protect deficient individuals. Iron overload can occur in some individuals with G6PD deficiency. In one study, 50 Sicilian patients were evaluated with G6PD deficiency under steady-state conditions, and results were compared with those for 50 control patients. Hemolysis and iron indices were studied to evaluate the iron balance. These patients could be considered to be at risk of iron overload as a result of increased bone marrow activity. Trace amounts of naphthalene are produced by magnolias, toilet bowl deodorizers, types of deer, and Formosan subterranean termites. Exposure to large amounts of naphthalene may damage or destroy red blood cells. People have developed hemolytic anemia after ingesting mothballs or deodorant blocks containing naphthalene. Those with glucose 6-phosphate dehydrogenase G6PD deficiency are especially susceptible. There are many drugs and foods to avoid if you are G6PD deficient. A good place to go is www.g6pddeficiency.org to get a complete list. Some more common drugs that are contradicted when G6PD deficient are chloroquine, chlorpropamide, dabrafenib, dapsone, glibenclamide, glimepiride, glipizide, mofanide, methylene blue, nalidixic acid, nitrofuratoin, norfloxacin, pegloticase, primaquine, probenecid, quinine, rasburicase, nitrite, sashimar, sulfadiazine, sulfasalazine, sulfus oxazole. Vitamin C as an ascorbic acid. G6PD deficiency.org reports that it is safer to consume vitamin C in food sources rather than ascorbic acid. Sulfamethoxazole, trimethoprim, glimepiride, methylene blue, and LVRB, CYB5R3, and G6PD, pegloticase, rasburicase. Aspirin has been also known to destroy the red blood cells of G6PD deficient individuals. G6PD A357G RS 1050757 C1311T RS 2230037. A total number of 48 individuals, approximately 46.6%, were G6PD deficient. 83.3 of these carried G6PD 1311T93C, with enzyme activity ranging from 1.8 to 4.8 UGHB -1. 3 novel single nucleotide polymorphisms, also known as SNPs, RS112950-723, RS111485-003, and 1050-757, were found in the G6PD 3' untranslated region, UTR. Strong association was observed between haplotype 1311T93C and RS1050757G, which is located inside the 35 base pairs or BP AG rich region. 25% of the American population, 12% of the European population, 94% of the African population, and 15% of the Asian population has a C allele for G6PD RS1050757. Approximately 80% of people injured by a class of antibiotics called fluoroquinolones have run the C allele that have run their data through Sterling's app at www.MTHFR Support.com and have shared their findings with Sterling Erdi. Fluoroquinolones have been labeled as a risk for people with G6PD deficiency. G6PD, G6PD A positive RS1050829. Both female and males are more vulnerable to anemia. G6PD IK-BKG RS1050828. Both male and females are vulnerable to anemia. G6PD 1K-BKG G6PD Mediterranean RS5030868. This variant is related to hemolytic anemia in response to therapeutic drugs and fava beans. Other genes that have been known to affect G6PD deficient individuals are HFE, known as hereditary hemochromatosis. When this gene is not functioning, a patient can have a hard time metabolizing iron from the liver. SOD2 A16V SOD2 is iron binding. When not functioning properly, this gene can also cause iron overload. RAB6B has been related to elevated serum transferrin saturation. Now remember, if you have concerns you may be G6PD deficient, contact a practitioner who understands